Now that we've looked at prisms, cylinders, pyramids, spheres, and cones, now we need to talk about similar solids. All right, so with that being said, similar solids are proportional to each other. Kind of like similar shapes. So what that means is they're going to have the same ratio from, say, like your height, for instance. Your height of your prism is going to have the same proportional ratio as the area of the base to of solid A to solid B. So let's look at this. So we're going to draw two prisms. And I'm going to give you some lengths based on these prisms. Okay, so what that means is if I were to truly have them proportional to each other, the height would be the same ratio as, say, this front part, say like the 4 to the 6. Okay, all of those ratios would be the same. So I'm going to start off with, we're going to have it as B over A. Okay, so I'm going from box B to box A. Well, box B's height is 12, box A's is 8, and then we've got 4 to 3, and then 6 to 4. Does everyone see how the different lines or edges line up? Okay. So what happens right now, I can't see whether or not they truly are. I can just say, no, the numbers don't match up. Well, you can't just do that. You have to simplify your fractions. Don't change it to a mixed number, just simplify and reduce. So for instance, 12 over 8 is really 3 over 2. 4 over 3, I can't reduce it. And 6 over 4 is 3 over 2. So right there, you can see you've got a 3 over 2, a 4 over 3, and a 3 over 2. So these are not similar solids. If all three of those ratios were a 3 over 2, then we would have a similar solid. Ratios are not all the same. Again, if they were to all be 3 over 2, 3 over 2, 3 over 2, then we would have similar solids. Now, when we're talking about this, right now we're only working with one dimension. So this is what we call a scale factor. My scale factor is a ratio of A to B. So let's talk about a surface area. Surface area ratio, we know that our units are squared. So that means that we're going to have A squared to B squared. Well, what do you think the volume ratio is going to be? The volume ratio, we know our units are cubed. So it's A cubed to B cubed. So what does this mean for us? Let's say, for instance, I had a surface area ratio of 16 to 49. My goal is then to find the volume ratio and the scale factor. Personally, I think the scale factor is easier to find because we know that what our A and B are then to figure out our volume. Some of you will be able to figure out your volume based on your surface area ratio right away. But to find my surface area ratio, to break this down, I know it's A squared to B squared. Well, to get to A to B, I'm going to have to take the square root of 16 and the square root of 49. And I then know that my scale factor of A to B is 4 to 7. Well, I can now find my volume ratio. I know that my volume ratio is 4 cubed to 7 cubed. Well, 4 cubed is 16, and 7 cubed is 343. So I've now calculated my ratios. Okay. So for you guys, I'm going to give you 2 solids. You're going to have to figure out what the scale ratio is. You're going to have to figure out the surface area ratio and the volume ratio based on the actual formulas. And you will be able to see if you were to truly use your volume of the first item to the second item, that the ratio would be the same. So we're going to look at cylinders here. All right, so I've got can A and can B. I need to find the scale factor. So go ahead and calculate that. Make sure that both of your proportions are correct. Now that we found our scale factor, which I can see here that I've got 12 over 8 equals 6 over 4, which I already know based on the ones that we've done before. It was 3 over 2. So now I want you to calculate your surface area ratio. Go ahead and do that. So for the surface area ratio, I don't even have to find the surface area. I can just use my scale factor numbers and already know what my surface area ratio is. So I've got 3 squared over 2 squared, which is 9 over 4. I could also, if you really wanted to, you can calculate your surface area of your cylinder and of A to B. So for instance, for the surface area, if you really wanted to, you don't have to. I can calculate it as my LA, so we know it's 2 pi r, so 6, times our height, plus 2 times the area of the base, all over 2 pi r times the height, plus 2 pi r squared. When I calculate this, I get 216 pi over 96 pi. Well, when I reduce 216 over 96, I get 9 over 4. Notice it's the same thing, but if you find your scale factor, you don't have to go through all the work and do the surface area formulas. So go ahead and find then your volume ratio. Because you know that your scale factor ratio is 3 over 2, we're going to have 3 cubed over 2 cubed, which is then 27 over 8. Final answer.